Good evening, everyone. So let's begin with our presentation session. For now, we have only Anirudh. Anirudh, are you ready with your presentation?
Yes, ma'am, I'm ready.
Okay, so you can start your presentation.
Should I turn on my video or just the presentation is enough?
No, you have to turn on your video as well.
Okay. Sure, ma'am. Give me a minute.
Yeah, sure.
Yes, ma'am. Can I start?
Yeah, you can start.
Yeah, good evening, ma'am. This is my first Scrum meeting and I have been assigned with the project on MyFitnessPal. It is developed using Node.js and I am going to discuss about the SRS document requirements. So the requirements are first requirement is track your food intake. Mainly the intake consists of the quantity of the food, the calories per food, and the nutrition information of the protein, carbohydrates, and the fats of the food. And everyone should follow a strict diet, but sometimes also they need to give a cheat diet to increase their motivation. So we had it in another option naming cheat diet to track it. And the next requirement is setting dietary goals. So the dietary goals can be of daily, monthly, and quarterly, yearly basis. So each goal can be taken one step at a time. And the next requirement is having access to data information. So the user should have an idea about what are the food that he can take to set his goals. And it consists of a library of the different foods and all. And the next requirement is barcode scanning. Using multiple inputs from the user is a very hectic process. So user also mentioned a requirement about barcode scanning. So he can scan the barcode of any product. Then he can access the nutritional information which is stored up globally. Next, the user requirement is the tracking his fitness. So he can track food which he consumed, can track the workouts he did on a weekly basis, daily basis, and he can set goals and track it too. And the next one is using AI, optimizing his previous one and recommending the better workouts or better food and monitor and increase his future scope also. So thank you. Um, any questions regarding presentation?
Okay, so Anirudh, are you done with the presentation?
Yeah, ma'am.
Okay, so basically, can you show me the topic? It's just an overview or what? Because I think
Yeah,
we have.
it only the SR requirement specifications about how the app need to be done.
Okay, so in the further task, you have to build this website basically. Am I right?
Yeah, yeah.
Okay, so you can explore it more because, like, actually, the feature you are going to means inbuilt in your project, you can elaborate more because it's quite a small presentation, and I think all the aspects has not been covered. Are you getting my point?
Yeah, yeah.
So whatever features like your interface, how your interface, that what programming languages are you going to use while building, from which domain you are?
IT.
No, I mean,
Okay.
uh,
Node.js.
Okay, notice. Yeah, so you can elaborate more about the programming language, what backend you are going to use, what front end, and how your interface will look like. So these are the certain things you can include in your PPT, so that when you move on with the further projects, so you will just give a quick wrap on in the coming presentations, and then go ahead with the technical part. Okay.
Yes, ma'am.
Okay, so this is all from my side. So I will provide your scores and feedback on your email. Do you have any questions?
No, ma'am.
Okay, so you can leave now.
Thank you, ma'am.
Okay. So, guys, you have not raised your hands. I cannot see who is going to be next. So, you guys can raise your hands. I will go in that sequence. Yeah, first we have Pushpak. You can start with the presentation.
Yes, ma'am. Am I audible?
Yeah, you are audible as well as visible. Anirudh, you can stop sharing your screen.
Yes, ma'am. Is my screen visible, ma'am?
Yes, your screen is visible. You can continue.
Yes, ma'am. So the task, good evening, everyone. The task given to me was prescriptive analytics. And I'm Pushpak Suryawanshi, and I'm from machine learning and deep learning group. So these is the table of contents which I'm going to present today. So first one, we are going to see the analytics and types of analytics. Then we are going to see the task given to me and the objectives of what the task consists of. Then we are going to see the various machine learning algorithms applied and the time series analysis, then algorithm optimization, then sensitivity analysis, and finally we'll see the conclusion. So first, the analytics and types of analytics. So firstly, what is analytics? So data analytics is the process of examining, cleaning, transforming, and interpreting data to discover meaningful insights and make informed decisions. Basically, data analytics is all about finding valuable information from a pile of data. So next, we'll see what are the types of analytics. So the first type of analytics is descriptive analytics. Descriptive analytics consists of the information and it tells about what happened in the past. For example, uh, uh, suppose if a company's sales is going, uh, a company faced loss at the previous year, and we want to find out that why the company faced loss in the previous year. So descriptive analytics will tell us that why a particular event occurred and what was the reason behind it. So diagnostic analytics tells us that what was actually the reason behind it. For example, if a company faced loss at previous years and what was the particular reason behind it. For example, if it was COVID or because of the recession. So diagnostic analytics tells us all about it. Why a particular event occurred. So next is the predictive analysis. Predictive analytics tells us that what might happen in the future based on the current trends. So it is all about making predictions about future events. And the last one, which we'll see in detail today, is the prescriptive analytics. So prescriptive analytics is all about providing recommendations on what to do based on data. Means it tells us if we have a specific goal that if a company has a specific goal that if it has to achieve this target in next few months, so how it can achieve. So this is all about prescriptive analytics. So these were the 4 types of analytics. Next, we'll see the task and the objectives. So the task given to me was using prescriptive analytics techniques to optimize the inventory management. And secondly, using optimization algorithms such as linear programming, integer programming, and mixed integer programming to find the optimal solution. Next, evaluating the solution using appropriating evaluation metrics such as R-square, RMSE score, etc. Finally, using sensitivity analysis to identify the impact of changes in parameters such as demand, lead time, and holding cost, and minimizing the optimal cost. So let us see the various machine learning algorithms and time series analysis. So firstly, the data set given to me was, it was from the Kaggle, and it consisted of the historical product demand for a manufacturing company. It consisted of 5 columns, namely product code, warehouse, product category, date, and order demand. So product code consists of the codes of the product. Product warehouse consists of the warehouse from which the product is generated, and product category represents the category of product. Date represents the shipping of the product from the warehouse, and order demand from represents the how many demand represents the demand of the each product. So there are we can see there are 4 warehouses from which the products are shifted, and within the region, which region it is responsible for. So this was our data set. Next, we have applied. I have applied here the machine learning algorithms. I have applied here 2 machine learning algorithms, that is random forest and XGBoost. So what is random forest? So random forest is a machine learning algorithm that builds a collection of decision tree. So what is decision tree algorithm first? So decision tree algorithms, if we have a set of data points, so each date we have to calculate the value of the new data point, so we can calculate the average of the previous data point and assign its value to the new data point. It is called a decision tree algorithms. So similarly, a group of decision tree algorithms is a random forest algorithm. So what it basically does is it combines the outputs of all the individual decision trees algorithm and assigns a particular value combined as a whole to that new data point. So it is a very helpful algorithm to improve accuracy and reduce overfitting, making it a more powerful tool for various data analytics tasks such as regression and classification. So mostly random forest is used as it is very helpful algorithm, and it gives a greater accuracy than other machine learning algorithms. So second machine learning algorithms which I've used is XGBoost. So XGBoost stands for extreme gradient boosting. It is a popular machine learning algorithm used for both regression and classification tasks. It belongs to assemble learning category. Assemble learning is combining 2 or more machine learning algorithm to make a more powerful machine learning algorithm. So it is called as ensemble learning. So XGBoost comes in the category of ensemble learning. So this was all about machine learning algorithms. So next I've applied is time series analysis. So why I've applied this time series analysis is because that when I applied the machine learning algorithms on the data set, the accuracy the R-square error was coming very low. So I could not, so it was not predicting as per the need. So I had to use some other techniques to properly predict the demand. So I use time series analysis here. So what is time series analysis? So time series analysis is a data analysis technique used to analyze and data points collected and recorded or observed at successive points in time. So it involves studying patterns, trends, and dependencies within the data to make forecasts and draw insights or make informed decisions. So time series data is used in many fields such as healthcare, sports, economics, weather forecasting, etc. So the models which I've used here is ARIMA, SARIMA. There are also other models in time series analysis such as autoregressive, ARMA, that is autoregressive and moving averages. Here, ARIMA means autoregressive integrated moving average. Seasonal, SARIMA means seasonal autoregressive integrated moving average. So we'll see how its code works in the future slides. So this is the whole process of time series analysis. First, we import the data, then we clean the data, then we check the stationary. Stationarity means that we can't, while applying a time series to a data set, we can't just apply like that by applying the as we do in machine learning algorithms. First, we have to check the stationarity of it. Stationarity means taking stationarity means the trend of the data set must be constant and its variance and mean should be constant. So first we have to check the stationarity of it. If it is stationary, if the data set is stationary, then only then we can apply the model and predict according to it. Otherwise, the model will fail. So checking stationarity is the most important thing in time series analysis. So some important terms in time series analysis. So we have seen ARIMA model. So in ARIMA model stands for autoregressive integrated and moving average. So what is autoregression? Autoregression is a statistical model. If a model is autoregressive, it is if it predicts future values based on past values. So first we'll see what is ACF. In time series analysis, the two most important plots and graphs are the ACF and PACF. Or ACF means auto-correlated function, and PACF means partial or auto-correlated function. So ACF means a function which gives us values of autocorrelation of any series with its lags values. So what is lagged values? So consider an example here. So we have original time series 21, 22, 21, 20, and 19. And so and this is the lag time series by one lag. Why one lag means we have omitted the 21 value, that is first lag, and remaining we have considered as it is. So lag one correlation will be the correlation between 21, 20, this one and this one. So this is called the lag one correlation. So ACF means ACF gives us the values of autocorrelation between this lag one and the original value. And PACF means it is used to directly find the lagged value, and it does not need the original time series for it. So this was some important terms in time series. So next we'll look what is algorithm optimization. So algorithm optimization is the technique for improving the performance and efficiency of algorithm. So it consists of three techniques. First is linear programming, integer programming, and mixed integer programming. So linear programming is a technique used to find the best outcome in a model with linear relationship. Example, optimizing production and distribution to minimize cost while meeting demand and resource limitation in a manufacturing company. So this is the case in this data set. So in this data set, we'll use linear programming. Second is the integer programming. Where the numbers are considered comes under integer programming. So it is basically an extension of linear programming. And for example, the data set which consists of time constraints, such as assigning workers to shifts where the numbers of worker may be a whole number and not a decimal number. So in this case, integer programming may be very useful. So and the next is mixed integer programming. So mixed integer programming consists of linear programming as well as integer programming. So for example, where the distribution of where the linear programming integer both cases are considered. For that cases, mixed integer programming is very useful. So next we have applied a sensitivity analysis here. So what is sensitivity analysis? So sensitivity analysis is a technique used in various fields, including economics, engineering, etc., to assess how sensitive is the output or outcome of the model to a specific condition of the input. It helps in understanding the impact of uncertainty and variability in the inputs of the results. So sensitivity analysis can be used to evaluate the sensitivity of companies' net present values to changes in factors like interest, revenue, or production cost. So by conducting sensitivity analysis, decision makers can assess the potential impact of different economic conditions or assumptions on the financial feasibility of the project. So next, these are the steps we have considered in sensitivity analysis. So these we have first we identify the input factors, then we define ranges for these factors, then we select a measure, then we analyze how these changes in each factor affect the output, then we visualize and interpret the result. Finally, we draw the conclusion. So this is the proper workflow of how the code will work. So first we have gathered the data, and the data set was given by Hagveda from Kaggle. Then the step was data analysis. In data analysis, we do various steps such as data assessing, data cleaning, data preprocessing, and EDA. The next step, we build machine learning models. Here we have considered two machine learning models, that is random forest and XGBoost. The next step, as the accuracy was of the machine learning algorithms was very low, then we have considered time series analysis here. After that, we have done the algorithm optimization, and finally we have done the sensitivity analysis. So this is the proper workflow of the code. Yeah, so let's move towards the code. Yeah, so this is the code. First, we have gathered the data, and we have imported the libraries here: NumPy, Pandas, linear regression for model building, random forest, and XGBoost. Then we have imported the data set. Then we have considered the for checking the data set, we have printed the first 5 rows of the data set. We have 5 columns. Then we have taken the we have printed the last 5 rows of the data set. So we have so we have considered a small summary of the data set, that what the data set consists of, and what is the purpose of the data set basically. Then we have printed the columns of the data set. It consists of 5 columns. The data set of all the 5 columns are object, but we have here we have date here, so we will change the data type of in the next lines of code. Then here is the description of various features, that what are the different products, how many unique warehouses are there, then what are the different product categories. Then we have described the data set here using describe function. It tells us that how many values the data set consists of. Then we can see here over 1 lakh, more than 10 lakh rows are here, and from that 2000 rows are unique. And then we can see what is the highest product order demand, which is 1000. Then firstly we have changed the data type from of date column to date time, and then so this is the our data frame. So we have so then what we have done is the next step. So data gathering phase concludes here. The next step is data cleaning. So in data cleaning, we check the missing values, if there are any missing values or not. So we can see here there are many missing values in the date column. So we drop these date missing values to improve the accuracy. If we keep these the missing values, the accuracy of the model will be very low. So it is important to drop these missing values. So we calculate the percent of how many missing values are there. So it concludes to be 1%. So we drop it. Next, we do the exploratory data analysis. In the exploratory data analysis, we categorize the columns into numerical columns, categorical columns, and mixed columns. So numerical columns here are order demand, categorical columns are here are warehouse and product category, and mixed columns here are the product code. So we have considered here how many. Firstly, we have in exploratory data analysis we have to do the univariate analysis of each column. So we do the univariate analysis firstly of warehouse column. So we can see here warehouse J, warehouse warehouse I consists of highest order demands, followed by warehouse A, warehouse S, and warehouse C. So then we have plotted out the 10 most popular categories. Then we can see that category 019 has the highest order demand, followed by category 005 and 001. So these are the 10 most ordered categories, product categories. Then we plot a simple line plot related to order demand. So we can see here the date according to the years, the order demands we can see the variations of order demand with respect to date. But we can see here that the 2 years, firstly 2011 to 2012, the order demand is negligible. So it's of no point to consider these data points. So it's good to drop these data points, as it consists of no value and it can reduce the accuracy. So what we do is we consider only the dates which are greater than 2012. So this is the new 9 plot according to it, in which we consider the date greater than 1st January 2012. So finally we find the skewness in the data, which we get as 31. 31 means it is more positively skewed and it is not normally distributed. Then then the next step is performing bivariate analysis. So in EDA there are 3 steps. Firstly we consider univariate analysis, then we consider bivariate analysis, and then we consider multivariate analysis. So we have already performed univariate analysis. Then now we'll perform bivariate analysis. In bivariate analysis, we take 2 columns at a time and find the relationship between them. So firstly, we take the demand column and the warehouse column and find the plot. So accordingly, warehouse I stands first, then we followed by J and C, C and A. Sorry. Then we calculate the mean, and finally we conclude with this graph. Then after univariate, multivariate, and bivariate analysis, the next step is to do feature engineering. In feature engineering, what we basically do is we add extra columns which will help us to improve the accuracy of the model. So first, we have only data column here. So what we do is we take the date column and we add a new column such as week, month, and year based on that column. So here we have done a day of week, quarter, month, year, week, etc. Then we have set the features as day of the week, quarter, month, and year and week, and we have set the target variable as order demand. We have to calculate, we have to predict the order demand. So we have set the target variable as demand. So finally, we apply machine learning algorithms. I tried to apply all machine learning algorithms, but it was taking much time. So I consider here only the two most important machine learning algorithms, that are XGBoost and random forest. So here we predict the model, and we have already imported the necessary libraries in the first statement. Then we calculate the RMSE score of all values. We calculate the R square score and mean absolute error score. So accordingly, we get the final result as this. So it consists of that we get the RMSE value of 27,000 on average. So this means that we have approximately 27,000 units deviating from the actual values. This suggests that the model's predictions are not very accurate and the model is of no use. Similarly, we get the R square score of minus 0.00155, which is very close to zero, which indicates that the model is not accurate at all. And also we get the mean absolute error value of 7,000, which represents the absolute difference between the model's predictions and the actual value. So it is a lower, it should be lower mean absolute error, but we are getting a very high mean absolute error. So the model predictions have a considerable absolute error. So the model is of very less use or of no use. So accordingly, we have plotted the graph based on these machine learning algorithms. So these algorithms did not perform well. So we had to use time series analysis here. So in time series analysis, we first plot the box plot by the in x-axis we take the week, and in y-axis we take the demand, and we can see the box plot here. Next, we plot according to the year and demand, and month and demand. So monthly order demand and weekly order demand. So as we saw in the slide that while calculating time series analysis, it is very important to test the stationarity of it. So for checking the stationarity of it, we first plot the decomposition plot. So what is decomposition? So decomposition is mainly used for stationarity purpose to check the stationarity of the given data set. So we have here plotted a stationarity plot here, which gives us various values, the trend, seasonality, and residual values. So trend means how is the trend over the period of times. Seasonality means over in this period, what are the specific points where it actually deviated from the mean value. And residual means that it is a combination of trend and seasonality. So to check the stationarity of the data set of the trend, we use add Fuller test here. So in add Fuller test, the value as minus 2.1. So in add Fuller test, the value should be less than 5%. So at least it should be less than 5%. We get so it is described here that the 1% value is minus 3.5, the 5% value is minus 2.9. So we get more than 5%. So we are deviating. We have concluded the fact that the data set is not stationary. If the value was less than 5%, the data set would have been more stationarity, and so we could calculate the time series analysis, but this is not the case here. So first we have to make the data set stationary. So for it, we have calculated the demand in difference, and we get the plot according to it. Then again we calculate the add Fuller test here. This time we get the value as minus 6.7, which is less than 5%. So we can say that the data set is stationary. Finally, according to it, we build the ARIMA model, and we plot the ACF and PSCF plots as shown here. So in ACF and PSCF plot, as we can see, we consider the first value as it lies between the confidence interval, and in the PSF we consider 0, 1 and second value as it lies in the confidence interval, and here we consider the first value as as it is between the confidence interval, and the blue shaded area is the confidence interval. Then we test the model based on ARIMA model in this training data set, and so we have considered the second data point here and the first data point here. So auto-regressive, we considered the orders 2 year, and the moving average, we consider the order 1 year. So we get the model ARIMA summary as it consists of various values such as coefficient, standard error, Z-score, and the confidence interval in which it lies. So finally, these are the graphs from residuals of ARIMA model, and these are the test set. These have plotted the graph of test values and the training data set. So we get the graph. So we can see here it is little deviating from the actual value. So we have calculated the RMSE score here, which is 335, which is quite more. So, and for we have also calculated the future values of from the year 2016 onwards. So we can we get this values in the future. So, and this is the combination graph of the test set and the prediction set. So the orange line is the prediction set, and the blue line is here the test original values. So we eliminate the test values and we only consider the prediction values. So here the time series section is concluded, and then we do the algorithm optimization here. In algorithm optimization, first we define the specific parameters according to us. We consider the mean of the demand. For initial inventory, we take the sum of it. For max inventory, we take the initial inventory into 2 raised to 2 into 2. Sorry. So, and we have considered here that we can consider any values here according to our choice, but we have to specify a particular product cost and holding cost, and what are the specific time period that the warehouse can hold. So we have defined here the holding cost, the ordering cost, and the holding days. Then we have defined the objective functions and the constraints for it. For this C is the objective functions, and we have defined this formula for it: holding cost into holding days plus ordering cost. Then we have specified the upper and lower bounds for this value. Finally, we have solved the optimization problem, and this is the output that we are getting. This the success means true, that the optimization is terminated successfully. The fun value means that what is the optimal cost value function. The X means the lower bound value. Neat means the number of integrated number of iterations. NIT means number of iterations. So here the number of iterations are 0 to reach the minimal cost optimal solution value. So this is the lower bound and upper bound. And MIP means MIP means that mixed integer programming. It is 0, that so that 0 means that we have not applied mixed integer programming here, as we have applied linear integer programming, so its value is 0. So this is the optimal solution that we have got. The total cost is 5,43,880. That this is the total cost for the warehouse to ship products from. So the last step is to perform sensitivity analysis. So if we have considered here the a specific input parameter, and from that input parameter, how the final output value will change. So we have considered here demand change of plus 20%, holding cost change of minus 20%, and lead time change of plus 50%. So accordingly, we have calculated the new demand, new holding cost, and new lead time. So we have defined a function for sensitivity analysis here, and we have this is the formula of calculating the new cost function, new optimal cost function. This is the output that we get from by applying that function. So the original cost that we got was 5,43,000, but according to the input parameters and applying sensitivity function, we get the cost value as 3,06,155 according to the input parameters. So this is the final graph of original value versus the sensitivity value. So coming back to the presentation. So these are the results that we get from a different section. From ML algorithm, machine learning algorithms such as execution, random forest, we get this output. From time series, we get this output. From algorithm optimization, we get this algorithm this output, and finally from sensitivity analysis, we get this output. So finally, conclusion. In this task, we use prescriptive analytics to optimize the inventory management of a given product. We use machine learning algorithms such as random forest and XGBoost to predict the future trends of the product demands. Then we use time series analysis. As the machine learning algorithms could not perform well, we use time series analytics to predict the future trends. Then we used optimization algorithms here, like linear programming. Then finally, we use a sensitivity analysis to gain more insights based on the input parameters and predict its outcome based on specific situations. So this was all about the task. These are the references from which I took some information from. So if there are any questions, you can contact me at my email ID. Thank you, ma'am. This was all about the task.
Okay, Pushpak, your presentation was quite good. The flow you maintained, the way you explained the demonstration, and from my side, you covered all the points and explained each and every point. So, do you have any questions?
No, ma'am.
Okay, so I will provide your scores and feedback on your email. Okay.
Okay. Thank you, ma'am.
Okay, welcome. Okay, next we have Aayush. You can start your presentation.
Okay, ma'am. Am I visible, ma'am?
Yeah, you are visible.
Is my screen visible, ma'am?
Yes, your screen is visible.
Good evening, ma'am. Good evening, everyone. My name is Aayush Saini, and my group's name is AWS DevOps. Today, I'm going to present in front of you how to create a Linux instance on AWS EC2. So these are the points of discussion. First, we are going to know what is AWS. Then we will discuss about the EC2, then benefits of EC2. Then we will know the steps to create a Linux instance. Then we will see the demonstration as well, and we connect the instance using our laptop, and followed by conclusion. So first, what is AWS? So basically, AWS is a cloud service provider platform which provides a wide range of services over multiple domains. Some of the domains are computation, storage, analytics, security, and a database as well. But AWS is not the only cloud service provider in the market. these days, as we have many service providers like IBM Cloud, Alibaba, Google Cloud Platform, Microsoft Azure, DigitalOceans, and many more. But AWS is special because it acquires the biggest part of the market these days, and there is a specific reason behind that, as AWS offers a very user-friendly interface and a very smooth process to deploy the applications on cloud. So now we are going to discuss about the EC2. So basically, AWS offers many services for different purposes, and EC2 is one of them. EC2 is basically a computation service which provides virtual machines known as instances. So using EC2, we create virtual servers. These servers are known as instances, and these instances we can configure according to our need. EC2 reduces the hardware cost, as we do not need to maintain any physical hardware for the servers. And these servers, basically what we do in EC2, we just create a virtual server, and this server will be hosted on the data centers provided by EC2. So basically Amazon is going to manage those data centers. We are just going to pay for what we use. Suppose we have made 3 virtual servers, so we are going to pay only for those 3 servers, for those 3 servers. And now there are multiple features that EC2 provides, and that's why we use EC2. Now we are going to discuss about the features. The first one is scalability. So it is a very special feature that EC2 offers. Now as an example, we can see that if in real life, suppose I'm running a cloud kitchen and I take orders on the website. Now suppose on normal weekdays, the traffic on my website is 20 to 30 orders per day, but on weekends I got the orders like 100 to 150 orders per day. So the capacity increased drastically. Now if I'm maintaining a physical data center or I'm maintaining a physical server, i have to maintain the I have to maintain the server for the maximum capacity for most of the time. So, but my server is used in full capacity for almost 6 to 8 days. So rest of the time it is useless, but I have to pay it for the whole month. I have to pay the cost for the whole month. But if I'm doing the same thing on cloud, I don't need to pay any upfront cost, and I don't even need to maintain it by myself. I can just use a scale auto scaling feature of EC2. So what a auto scaling feature it basically does, it increases the number of servers, and it increases the number of servers automatically and decreases the number of servers as well. So I don't need to configure it, and I don't need to manage the maximum capacity of servers. I can do EC2 can do this automatically. Now the next one is cost saving. So if I'm managing the physical server, I need to pay all upfront cost when I'm going to buy the servers. But in EC2, I don't need to make any upfront payment. I can just pay for what I use, and this is the payment model that EC2 use, and it is known as pay as you go. Now flexibility, like the need of all the users is not same always. For this reason, EC2 offers various type of instances, and user can choose its instance according to its need. Now coming to reliability, and now if I'm maintaining a physical server, and due to any physical disaster or any natural disaster, suppose my server is destroyed, now the deployment of my website that was deployed on that server will not work anymore. But if I'm using EC2, there is a feature in EC2 which is known as multiple availability zone deployment. What happens inside it, like if I'm deploying my application in an availability zone, I can also deploy it in the multiple availability zones in just one click. So if the same thing happens with one of my availability zone, my website will be still running on another availability zone, and user can uh, serve the request from that availability zone as well. Now coming to security, AWS provides many security services as well to secure the deployment of any website or application. And for the security of EC2 instance, there is a term known as security group. So what security group is, security group basically provides security to the instance, and it works as a firewall. For instance, it controls the inbound and outbound traffic for EC2 instance. Now one of the very famous feature of EC2 is global reach. So EC2 provides global reach because as we have seen this uh, in the reliability feature as well, that it provides multiple availability zone deployment. So if our website is deployed in multiple availability zone, we can reach globally in just one click. Now we will see the steps to create an EC2 instance. So basically what we need to do, first we will log in into the AWS management console, then we will go to the dashboard, and in the dashboard, in the search bar, we will type EC2. When we will click on the EC2, our user interface will come in front of us, and then we will click on instances. In instances, we will click on launch instance. From there, we will choose the Amazon machine image. So what basically Amazon machine image is, it is a pre-configured instance configuration, and from there are multiple AMIs, and we can choose any specific AMI according to our need. Now there are multiple instance types, and then we will configure an instance. We will give its name and some other details as well. Then we will choose, then we will add the EBS storage. So EBS is also one of the services that AWS provide. It is basically a storage service. So EBS stands for elastic block storage. It is a block level storage. Generally, if talking in layman term, it just work as a virtual disk in an instance. Then we will configure the security group. Then we will review all the or then we will review all the informations and configuration, and then finally we will click on the launch instance. We're going to see all these in the demonstration part as well. So now these are some screenshots. Like this is the management console that will appear in front of us after logging in. This is the dash this is the first UI that will appear. In the search box we can type any service that we want to use. Like it is showing recently visited, so here we will click on EC2. After clicking on EC2, we have to choose the operating system that we want to host on instance. Like if we are going to create Linux instance, we will choose Linux. We can choose Mac OS, or we can choose Windows as well. When we will configure the instance, first we have to give it a name. We will give it a name, and then we will do the further configurations. Now there is an option while configuring an instance. There is an option for key pair. So what basically key pair is, in general terms, key pair works like a login credentials. Like if we are logging to any website, we need a username and a password. So basically key pair is a username or password to connect to the instance. If we have created an instance using EC2, and our instance is running successfully, and now we have a laptop and we want to access to that instance using that laptop. So how we can do that? We will do that with the help of key pair. So in key pair, there is a public key and a private key. When we create the key pair, we will see this in the demonstration part, like how we download the key pair. In the key pair file that we download, it is basically the private key that we need to provide to a specific software while connecting to the instance. Now that specific software that will be used to connect to the instance is putty. So what putty is basically a free SSH client that allow us to establish a connection between our laptop and to that virtual instance. So now we are going to see the demonstration. Actually, I'm sharing the another screen, ma'am. Just give me a minute.
Yeah, sure.
Is my screen visible, ma'am?
Yes, your screen is with you.
Okay, it is like what it is. Is
Yeah,
there console home written in it, ma'am?
yeah, yeah.
Okay,
It's a
okay.
console.
So I have logged into my console, And as in the screenshot, the same screen is visible here. Now I'm going to click on EC2. Now as there is, this is the EC2 dashboard. There are all the features that we can use inside EC2. And from here, we are going to connect to click on instance. Now launch instance. Now I'll give a name to my instance, like I'm giving it the new one. Now I will keep the, like my task is to create a Linux instance. I will choose it, and now I will download the keypad. Here I will click on create a new keypad. Now I give the same name to my keypad as instance. It is not necessary, we can give any name to create a keypad. I'm just giving it to keep remembering it. Like I'm going to download it, I don't want to miss it. Now I'm going to download it in ppk format. Ppk is basically putty private key, so I'm going putty software, that's why I'm using it. If I have Mac operating system, I don't need to download ppk file, I can directly download .pam file and I can use it for SSH connection. Now as my ppk file has been downloaded, now I'm going to do the SSH connection. That's why it is allowed. Now as we are creating just a basic instance, we are not going to change any other specifications, like we are not going to change any VPC. And I'm going to click on launch instance. Now my instance is launched. Now I will click on instance. Here I select my instance, and now it is showing instance test pending. We have to wait till when it will show running, and we have also wait for the status check. There are two status checks, all those two need to be passed. Instance state is running. By clicking on instance, we can see the details of our instance that we have selected. It will show some details here, like it is showing the public IP address. It is taking time for the status check. Okay, till when it is happening, we can do the putty thing. Here we are clicking on it. From here, we will copy the public IP address. Now we are going to open putty. Here we need to paste the public IP address. Now we are going to the SSH. In SSH, we will go to the authentication, and from here we will go to credential. Now here we need to import the .ppk file. That is a new one .ppk. Let's open it. It is still initializing. Now we have to give the name of our instance. By default, the name of that instance is EC2 user. Now as we can see, our Linux instance is running successfully. Like we can perform Linux operations in it. It is showing the file I created. Like I have the spelling of the file is wrong, but we have created the instance. And now if I want to see if that is the instance that I create, I can run this. Who am I? Who am I? So the instance is running like that. I think I forgot that command. Now if we want to close the session, we can just close it like that. If we want to do any work, now we can use this instance as a virtual machine. Like if I'm using my laptop, it is on Windows operating system, and I can perform many operations in it. Now the operations that we perform on Linux operating system, we can do all those things inside this Linux as an operating system that is installed in a laptop. Now I'm going to end this session. So now let's come to the conclusion. In this presentation, we have learned about the AWS, and then we learned about the EC2, and there are many other services that AWS provide. We have also discussed about how to create an instance on EC2. We have seen a very smooth process of creating any kind of instance on EC2. We have discussed the benefits of EC2, and we have also seen the security that EC2 provides. So here I'm done with the presentation, and these are the references that I used in my that I used to make this presentation. If anyone has any question, please feel free to ask.
Okay, Ayush, are you done with the presentation?
Yes, ma'am.
Okay, your presentation is quite good. The flow you maintain, and while demonstrating, you are explaining each and every point. Okay, slightly that command did not work. You can look into that.
Yes, ma'am.
Actually, okay. So can you, I have a just question. Can you tell me that what are the possible storage options available in Amazon EC2? For instance, possible storage options. Any idea? Something?
Possible storage options, ma'am. If we want to attach a storage to an EC2 instance, we generally use EBS volumes. Like we create a volume in EBS and then we attach it to the instance. Like we can configure it according to our need. We can choose the storage according to our need.
Yeah, okay, perfect. Rest from my side, your presentation was okay. So I will
Okay.
provide your scores and feedback on your email. Do you have any question?
No, ma'am.
Okay, so you can hear.
Okay.
So next we have Kanchana. You can go ahead with your presentation.
नहीं अभी तो हो रहा है.
Kanchana, are you sharing your screen? Kanchana, actually, I cannot hear you. Kanchana, your voice is not audible to me actually. No, sorry, I cannot hear you. Whatever you are saying, please try to write in chat. I'm not getting you. Please see the issue. Kanchana, are you able to hear me? Okay. Actually, we don't have any more interns, so you have to resolve the issue now only. See if it's possible to resolve the issue for now. Otherwise, you can give your presentation tomorrow. Though I am here, I am waiting for you. If you are able to resolve the issue, so please let me know. Yeah, sure. You can take your time.
Actually, ma'am, I have one question.
Yes. Yes, Aayush.
Ma'am, actually, the deadline of my task was showing 24th, and I scheduled my presentation on 22nd, but on 22nd it was Saturday, so my presentation is scheduled for today. So is it going to be considered after the deadline?
No issue. Because we have off for Saturday, Sunday, and Monday, na? So no problem with it.
Okay, okay, ma'am.
Okay.
Hello, ma'am.
Yeah, yes, Anshita. Now I can hear.
Shall I start, ma'am? Is it okay?
Yeah.
Okay, ma'am. Actually, very sorry, ma'am.
No.
I don't know why my laptop is not taking internet properly today. That's why I can't even able to switch the meeting.
No problem. You can go ahead with the presentation.
Was my screen visible, ma'am?
Yet not. I can see a black screen. Yeah, now it's visible. You can continue.
Okay. Okay, ma'am. So firstly, very good evening, ma'am. My name is Kanchana Ganga Daita. I have completed my graduation at Jawaharlal Nehru Technological University in Hyderabad. So the domain I have chosen was embedded systems and IoT. So this is my fifth task, and the project I have given was developing a component specification document for an air quality monitor. So firstly, why we have to do this project means we have already seen what are the key components and how the air quality monitoring system works, also how it the prototype work, how the software simulation works. So if we want to develop from the scratch, we need to know each and every component which is used to build an air quality monitor. Also, we need to know particular specifications for that. So for that, let's dive into the document. So I have been asked to uh, do a documentation, ma'am. To give a brief, I have actually made a PowerPoint presentation also. So firstly, let's see the brief points in this. After that, we'll dive into the documentation. So what are the contents? Introduction, and we'll look into the significance and story of this project. After that, we'll look into circuit and block diagram. After that, we can know the key components from the circuit diagram. Then we'll go into explanation. After this, all the components and explanations of this component will help us to understand the working principle of this project. After knowing the working principle, we can select the particular type of air quality monitor we require regarding our application, so that we need to know about the types of air quality monitoring systems. After that, we should obviously know the pros and cons of every other project we do, and we also need some real-time examples and applications for this, followed by conclusion and future. So firstly, what is an air quality monitoring system, and why do we need that? Actually, to measure the contaminants, gases, the air, and the particulate matter coming from the UV rays, also the temperature, humidity, pressure. These are all the required measures we need to take in the air. So why? Because actually we need to measure the pollution level, right? Not only to know how much pollution is present, but also for the researchers, for the projects, for domestic applications. Also, there are a lot even more applications. We'll go we'll get to know once we dive into our presentation. So for all those applications, we obviously need an air quality monitor. So uh, suppose let's take an air quality monitor has already measured the values or contaminants which are present in the air. But how an output can be retrieved from that? How a person who's working on that can know what is the percentage of oxygen present in the air, what is the percentage of carbon dioxide present in the air, like that. So it comes with a user friendly components. For example, user information systems like LCDs, LEDs, or any displays such as when the microcontrollers are used to build an air quality monitoring system, that microcontrollers can be connected to any PCs or laptops. We can store, we can just examine the data. Also, we can store the data for future purposes too. So these are all comes under the main requirement for doing this project. Also, it allows the uh, application of one of the most important projects today. So this is the need of doing this project. Also, we'll dive into the significance even more. So for firstly, actually to know about the significance of this project, we have a lot of applications. For example, industries, gas stations, research areas, domestic applications, hospitals, and some projects which are done by scientists, etc. So let's talk about each and every application. Firstly, why we need these in the industry case? Because each and every industry will release a lot of contaminants. We already know that it may contain a lot of chemicals, a lot of gases, which is not even good for the people working here to inhale them. But it is an impossible thing to filter all those gases even before releasing them. So what we have to do is we just have to measure what are all the contaminants or what are all the unwanted gases present in the air, and what is the particular diagnosis we can follow to remove all those. So that is one of the main requirements in the industry. Second thing is gas stations. Gas stations, for example, we may have gas leakages even in our domestic applications also. We may have gas leakages. Also in the gas stations such as petrol bunks or any gas stations in other countries also, there is a requirement to measure the levels of gases. Even if a single percentage, like 0.1% is increased beyond the prescribed level, means it may cause a huge impact, huge negative impact into the whole city. So that we need to take care of all of those. And third thing is domestic applications, which I have already mentioned. Suppose we can take an example. If a house has a gas leak, some gas leak. So if we doesn't identify it as soon as possible, like if we doesn't identify it in the minimum time, means it may just pass to the whole neighborhood, also to the whole city, even if we didn't even take care. So that also causes a lot of disturbance to the whole people who are living, the whole city who are living in that area. So that is one of the applications. And in hospitals also, we see a lot of air quality monitoring systems which measure the level of oxygen in the oxygen present. Also, we can identify the oxygen present in the human blood too. Next, coming to the projects, there are so many researchers and so many scientists working on this project. So for helping all of them, this is one of the machines which can easily help them to detect the different kind of contaminants or useful gases that are present in the air. So this is the main significance of this project. So this is an example of an air quality monitor, how it shows the result. For example, if it is below the prescribed level or below the, actually we can give a threshold value or else we can give a limit to it, like 5 to 10% limit. So if it is below or above the 5 to 10% level, for example, let's take we have given 100 as the prescribed value. So if it is 5 to 10% below or above the 100, the value 100, it will show good. If it is exactly nearer to 100, it will show fair. But if it is even very far from 100, for example, if it is not even lesser or greater than 5 to 10%, it is even more greater or lesser, means it is so bad. So these are all the different types of conditions which in a small, just by getting a small message, we can just easily quickly measure the air quality. So that also this is very important for that application also. It is fast operating device. So that is one of the advantages in the system. And actually in the old times or in the by using the previous technology, it wouldn't be this portable, this easy to operate. It used to have a lot of components, even all of them should be get connected at the particular place. Only it is, if one air quality monitoring system is built, means it should be only used at that particular place only. For example, if it's built at once, it should be used only for that area only. It is not like operating in a remote area where we can use it or where we can take it. It's not portable also. Also, it used to be high cost. Also, it used to be high in weight also, so that it's not that accessible. But as technology has improved, we can even have a lot of applications with a single air quality monitoring system. We can use it for both indoor and outdoor purposes just by changing some of the ratings of the components. So, as the air is one of the major cause for infections, allergies, and eventually it also causes death to some people. So, for all those, we need to remove the unwanted molecules present in the air or some unwanted contaminants. So for that also we need to firstly know how much is present in the air, what is the oxygen level we are inhaling, is it enriched or deficient, like that also. So these are all the real-time uses or applications for this project. Here we can even observe smoke detection, particulate matter monitoring, gas leak identification, AQI determination, indoor and outdoor air quality monitors, air velocity, humidity, temperature, pressure. There are even more lot of applications. Those are used in real time. So coming to the block diagram, actually this is we can use any input device. For example, we can use any kind of sensor. So mainly our application regarding to the industries, hospitals, domestic applications for researchers, projects, for all these applications, we need sensors because what are all the contaminants present in the air can be detected by sensors only. So if we use a carbon monoxide sensor, it will detect the level of carbon monoxide. Similarly, if we use oxygen sensor, it will detect the level of oxygen. Particulate sensor means, I'm sorry, particulate sensor means it will measure the what is the particulate matter present in the air. For example, let's take UV rays. So we can't even UV rays are invisible. We can't even see what is the contaminants present in the air. Even though we can't even see any kind of contaminants present in the air, but UV rays are something which we can't even feel that it was only invisible and it causes a lot of problems also. So that kind of contaminants can be censored by this particular sensor. Also, there are a lot of types which comes with different ratings, which are feasible for our different applications. Smoke sensor. This is one of the most important and one of the most used sensor we can say because smoke sensor is also used in domestic applications, even for small industrial purposes. Also, it is a necessary thing. And coming to the computing device. The computing device can be even an Arduino board or any microcontroller or any 8051, 8257 or any microprocessor too. You can also use a Raspberry Pi or something else. But it computes the input values that are given by all these sensors. We can even have more number of sensors. For example, NO3 sensor, CO2 sensor, O3 sensor to detect the level of ozone, etc. So all these are used for computation in this board, and it will just display outside. So LCD display. What is the LCD display? It just displays the value of. We have seen in the previous diagram on the LCD display. It is showing that air quality is good and the temperature is so and so, pressure is so and so, humidity is so and so, velocity is so and so, like that. So in this LCD display, we can have an option to visit different kinds of parameters which are measured by these sensors. Also, what are the different results after computation by this board or by this device? So LCD display comes in different dimensions. We can use 16 by 2 LCD display for a feasible use. And data logger. Data logger is a device which can count the values of output. Also, it stores the single bit every time. So whenever a data is displaying on the LCD display, it stores on it just holds the data onto the LCD display so that we are able to measure it, we are able to note it down, or else we are able to store the data into something else. So it stores one bit at a time. So by using data logger, we can store it up to the next measurement so that it can be feasible to us even to record all the everyday data also. And GPRS modem. GPRS modem is receiving part. It creates a receiving path from the computational device to the output. So it creates a path by using some technologies and internet. It creates a path where we can get the output from this board onto and to the LCD display. We can also use different types of systems here. One of the major used applications are collected by me. Actually, LCD display, data logger, these are all one of the majorly used output devices which are used for an air quality monitoring system. And this is the circuit diagram. So we can see we have used Arduino UNO R3 here. And as I have already said, we need a PM 2.5 sensor and BME sensor, which is used for measuring temperature and all. And MQ135 is a gas sensor. You can also have different types of sensors such as CO2 sensor, which particularly measures CO2, and VOC sensor or ozone sensor, which only particularly monitors ozone or O3 present in the air. So how the connections are made, we'll see later. We'll just see what are all the connections we need to make. So firstly, PM 2.5 sensor, it has 5 terminals: receiver, transmitter, input, ground, and reset pin. So in the tall pins, set reset pins. So in the tall pins, if you want to make the connection to that, it will turn to set, or else it will turn to reset. Reset means it will just clear all the data until then measured by that sensor, and it will start from zero again. And coming to transmitter and receiver, whenever we need to transmit, we have to connect TX, and whenever we need to receive, we need to connect for RX. And coming to 5V and ground, the 5 volts is the minimum input voltage that we give to any of the electronic devices. So 5V is the input device which we also connect the 5 volts pin of the Arduino. And ground pin of this is to be connected to the ground pin of the Arduino. Similarly, the BME sensor is also having 4 pins. SCL and SDA are using the bus topology. So here, that is a single bus. If we need to transmit any information from this sensor to the Arduino, there is just a single bus, and directly the information passes from SCL. In other cases, we'll have star topology and ad hoc topology, in which we have to just send a sensor. We have to send a message to a device that we are ready to send the data from the BME sensor to the Arduino. Are you ready to take the input data? So we need to ask like that. There is a device in between. We need to send a message there, and we need to ask the device that are you ready to receive the message? We are sending a data. Then after its acceptance, we need to send the data. So it takes a lot of time. But this BME sensor comes with a lot of advantages. We also gonna look into them later. The main advantages are having bus topology from SCL and SDA, because these two sensors have it takes less time, as we don't have to use any third-party device here. We can directly send SCL and SDA data to A4 and A5 pins of this Arduino. These are address pins. A0 to A8 are address pins. We got to learn this in the next slide. And MQ135 sensor, this sensor comes with a lot of advantages, as I said before. Like the BME sensor, it also comes with a lot of advantages. It has a main advantage that it gives input in two ways, both in analog and digital way. So that in whichever input is required also decides the amount of air quality present in that. That is one of the uh, different thing in this sensor. So coming to Arduino, actually we have a huge explanation in this in the Word document. Let me pause and switch to the Word document now. Yeah. Okay, so the same here. The list of components are circuit diagram and all, and the introduction is the same that we have also seen in the presentation. We can use this in even urban industrial areas, special nature conservation areas. Also for we can directly look into the LCD display. We are not even have to set up any of the output devices to make the output display. Not even there is no need of clicking any buttons, or there is no need of switching any operational devices to make the output display. It accidentally displays whenever the output has been computed by the microcontroller or an Arduino board. So this is the significance and story behind the project, as we have already seen, and this is the circuit diagram. Now let's dive into the key components. So there are many ways to build the circuit of an Arduino board or an air quality monitoring system. There are many ways to build, but what we have chosen is connecting Arduino we have selected Arduino as the main device, but because since our very first project from this air quality monitoring system, we are following Arduino. So from the same step as we are building level by level, first is to learn what is an air quality monitor, then what are the components required to it, then the simulation and different types of air quality monitors available in the market. After that, building a prototype, and now what are the key components in detail along with the specifications. So as I have already said, Arduino UNO R3, MQ135 gas sensor, PMS225, PM2.5 gas sensor, BME sensor, Raspberry Pi connected device, LCD display, and software system for simulation. These are all the required components. Let me start with Arduino UNO R3. The rating is UNO R3 actually. It also have Arduino NU board for it like that. So what are all the inputs? As I have already said, we have already seen in the block diagram that for any controller or for any computational device, the inputs are sensors. And we have to connect the VCC and ground pin to the 5 volts and ground to the Arduino. As VCC is 5 volts, we are giving the input. and the ground should be connected with ground pin of the any other computational, like any other sensor, and the ground pin all obviously reads 0 as default. And analog pin of the sensor is connected to the A0 of Arduino. We have address lines and data lines in the Arduino board. So D0 to D12 are the data lines, and A0 to A8 are the address lines. After that, we also have RX and TX pins, which are for and receiver. If it reads 0, so that it clears all the previous data, all the past data, and all the previous computations and applications, it will just clear. It will just start with a fresh.
Sorry to interrupt, Kanchana. I cannot hear you. I guess there is some network issue.
Sound. And Vin is obviously the input voltage pin. Ground is the ground pin. We can have 2-3 sensors connected at a time. That's it. Hello, ma'am.
Yeah, actually,
Hello,
your voice got break in between. Now it's perfect. You can go ahead.
Okay. Okay. So the microcontroller or Arduino board we have to use is 80 mega 2560. As I have said, it's an Arduino means we have to use UNO-R3. Similarly, operating voltage should be 5 volts and input voltage is can be 7 to 12 volts, because we all know for any electronic device it cannot be greater than 12 volts or 15 volts. But it is as we know, those are not power devices, so we can only give up to that. And input voltage limits are from 20 volts, and digital input output pins for 54. Totally, Arduino has 54 input pins, and analog pins are 16. We have already seen address lines, data lines, reset set, and RX, TX, ground pins, etc. So, as per input output pins, for those pins, we need to connect DC current for 40 amps, 40 milliamps only. If it is greater than that, means our ICs are going to burn. Similarly, for 3.3 volts pin, the current will be 50 milliamperes only. Flash memory. Flash memory means it is a memory device which is stored inside the computational device. It can calculate how many sensors inputs it is getting, so that it can be transmitted from each other. Like it stores it, and after that, when another sensor information also comes, it will just compute it. So that is the use for flash memory. Static random access memory. It can be 8 KB. These are all embedded into the Arduino board. And electrically erasable, programmable read-only memory. This can be up to 4 KB, and clock speed is 16 megahertz. Clock speed is obviously necessary because for single second, how many cycles are going per second is the clock speed, so that we also have to concentrate on. So this is the basic speed that by which our Arduino runs. And second most important device is Raspberry Pi. So actually, we have computed those devices. That is okay. But why do we use PC for computations only, right? It's a computer that the name itself tells that it is used for computation. So for that only, we don't have any PC in our constructional diagram, if you see. So that we need to have a Raspberry Pi or any other computer kind of device which can be helpful for doing some computation. It is so used, it is very much used in all the applications because it sizes only in a size of credit or debit card, which is super feasible for anything. And it can also be interoperable. For example, let me tell you, it can be even storing devices. It can be used as a television, like to display devices. It can be used as a mouse. It can be used as a monitor, also as a keyboard. So all these applications, like it can be simply, we can use a laptop or PC application by the single Raspberry Pi. It also comes with a different storage accessibilities, also published by different ratings. The most important and advantageous thing is it comes with a low cost. So let me explain you. This is the RAM which is present in the Raspberry Pi for the storage purpose. Also, we can have a different kind of storage values, for example, 2 GB, 4 GB, 8 GB, etc. So as I have already said, it provides gigabit for Ethernet. It provides USB and USB 2. These are for external connections. See, if you want to transfer data to any PC or laptop for our even, it also has power supply pin. By having USB-C C-type pin, we can give the power supply. And most importantly, it has a processor which processes all our computation. And it also has some specifications and rules. So it is a system on chip embedded system. We all know that. So it has to be on the version of Broadcom BCM 2837. The CPU we are using is 4X ARM Cortex. A53. It is 64-bit and 1.2 gigahertz. General
Kanchana, are you going on with the presentation? Actually, your voice is totally breaking.
it is the level of 6 and the random is 1 GB and LPD data.
Kanchana, I think there is some network issue. I cannot hear you properly. I guess there is some network issue, so let's wait. She has left a minute. Let's wait.
Hello, ma'am.
Yes, Kanchana.
Ma'am, I'm so sorry, ma'am. I don't know what's happening with my laptop today. It was not
No,
receiving internet button.
no problem. You can go ahead where you like.
Yeah, ma'am. Yeah, ma'am. Thank you. Yeah. So it was actually, it comes with a Bluetooth also. It was 4.1 classic level, which uses a low energy. Also, it has a memory card, which is an SD card. So it can be used as, we can use any of the memory cards. The SanDisk Ultra 8 GB class pen is suggested. And it has general purpose input outputs, which has 40 pin header and which is also populated. The ports which is having are HDMI, 3.5 and analog ports and digital serial interface ports also. So that's all about the Raspberry Pi. And coming to PM2.5 air quality sensor. So what is a PM2.5 air quality sensor? Actually, if we don't measure the contaminants present in the air, or for example, let me explain you what are the contaminants. As I have already said, UV rays are one of the main reasons for getting particulate matter invo- uh, involved into the air. So if we wanted to diagnose that, and if we wanted to separate the uh, uncontaminated air from the air, we need to use some sensor to identify that, and we need to diagnose it with proper measurements. So firstly, if we don't measure that means those gases will affect into people's heart, lungs, and it also causes some people, it also takes some people up to date. So the gas is detected by a photodiode. So we need to use a photodiode in this PM2.5 sensor, in which a photodiode is around the particular matter diameter will be in the around 2.5 microns, and the photodiode will be having the microprocessor microcontroller. This circuit is having the photodiode along with the microprocessor or microcontroller. So that will measure the amount of light, irradiance of the light scattering into the air. So it also causes a lot of health problems, if we didn't identify it as soon as possible. Here we can see there is an airflow channel. So when the inlet air is flowing into it and the photodiode is this, so it will trap the air. Also, it will have the laser light. So like whenever the laser light is falling on the chamber, it traps the light, and it by having the microcontroller in it, it just processes the irradiance value, and it will be blown through a fan. And coming to the outside view of an air quality of an PM2.5 sensor, it will be having a detection chamber. So in this detection chamber, when the UV rays are scattering into this beam, the beam of light is scattering into this detection chamber, it will just detect what is the amount of irradiance of that light is. So if the irradiance is measured in watts per meter square. So per a unit area, what is the light focusing on, that will be measured. So from that irradiance value, we can say, is there any fault in that UV rays, or is there any fault in that air or not? So there are also some specifications for this. The size should be in this diameter, like in this dimension, 53 by 40 by 51 millimeters. Weight should be like this, and the 7 grams is threshold value. It can be the 53 is prescribed, plus or minus 7 grams is acceptable. Sensing range will be 25 to 500 micrograms per meter cube. As we have already said, it will measure per unit area. Also, after measuring that, it will be converted into per unit volume. Sensitivity, it should be it should be carefully measured according to the sensitivity. Like even a single percentage of contaminants present in the air which is missed by the sensor means it will be total affected to the whole measuring system, air quality monitoring system, so that we may not be observed into these contaminants, so that it may not cause the proper effective measurement. And power consumption will be 1.1 watt. We have to select such a sensor which is consuming this amount of power only. And 38 decibels of noise should be there. Apart from that, we should not encourage. So CO2 sensor. Actually, from the particulate matter sensor, what we have learned is it will measure the particulate matter present in the air, which is due to the UV rays or any beam of light scattering in the atmosphere. But this CO2 sensor or MH sensor is for measuring the carbon dioxide present in the air. Example, we people emit carbon dioxide usually, but what if it is not in the proper levels? For example, the indoor concentration can get easily high because everyone present in the room will just exhale carbon dioxide. Also, it is not only dangerous, but also it can also cause drowsiness, tiredness for people, also decrease of productivity level. This is one of the most, this is one of the, this is discovered recently that carbon dioxide can also cause the decrease the productivity level of a principle. So what is an infrared principle? Actually, it has actually the CO2 sensor will have an infrared beam in between the sensor. So if the sensor is if the direct light focus on the one side of the input, it will just calculate the amount of irradiance value it has, like infrared irradiance value of that light, and will just display that value to the other side of the system. Here we have an example of that. In the circuit diagram, we may observe that. Yeah, here there is a working principle for the CO2 sensor. So what it does is, it has an optical filter. So in that, if the infrared light source is falling into the chamber, it filters that, and the IR detector, which is infrared rays detector, will be there. So what is the infrared source and what is the value of the infrared rays will be measured. After that, the gas will be released to the outlet. So with this measurement, we can sense it through this sensor. Also, we can send this data to the computational device such as Arduino or any microcontroller. And what are all the specifications? There are there are two versions of this. One is Z14 and one is Z19, which can be used as the input voltage. The positive voltage negative voltage should be for the ground, and positive voltage should be given for the VIN. Also, RX and TX are the receiver and transmission pins, and they should be connected with R and T. Similarly, if we use Z19, the VIN and V ground are same, and RX and TX also stays the same. Only the analog output voltage will be calculated here. In the Z19, we will get digital voltage. In this Z14, we will get analog output. PWM is pulse width modulation, and HD calibrations are same for the level. The display and the measurement of the chamber will also the level of that chamber will also be in the HD level. And pulse width modulation for like for example for 1 second, what is the how many pulses are calculating? Also, what is the width of that pulse? We can also modulate them according to the input values. And analog output will be, there are two diodes in this. The firstly, it can be up to 0 to 2.5 volts, and second one 0.4 to 2 volts. These are all the specifications for the CO2 sensor. And VOC and ozone sensors. Actually, ozone is also one of the most unwanted particle that is present in the air. So by using MQ131 sensor, which is also called as metal oxide sensor, we can use that principle for detecting this ozone. So it is like a normal household also, like it is generated in a normal household also by air purifiers, facial steamers, or any germicidal lamps. By using that also we can generate ozone. It's getting quite common that we are affected by that. So this sensor is responsible for detecting gases present in the air along with ozone. VOC is responsible for ozone. This also will be responsible for ammonia, alcohol, benzene, carbon dioxide, etc. So along with the measurement of all those gases, if we need carbon dioxide too, we can go with this. Also, if we need particular measurement for carbon dioxide, for different applications, we need different sensors. For that application, we can go with CO2 sensor. So this has two outputs. One is analog and other one is digital. It also has the constructional diagram here we can see. So what is the sensing material will be stayed on the top, and there is a heater at the bottom. So it calculates the resistance also. So if the maximum or minimum resistance is there, the target gases, it will sense the amount of heat in that, and it will give the resistance out of that. Here also, it will just mark the resistance from the resistance board. So what is the difference between the before and after measurement can be also observed. Here it also has some battery connected before and after the measurement. There are two ways. One is for low concentration, another one is high concentration. For the low concentration, we can get analog output, and for high concentration, we can get digital output. So for the model is MQ131. Here also model is MQ131. Standard connections will be there. Also, sensor will be undergoing some standard tests which are to be maintained properly. So if all the parameters are maintained in the prescribed levels, the standard tests are passed. And after that, we can have sensitivity and output voltage, concentrated voltage. These are all the parameters. And there is a voltage of 24 DC volts, which is provided for the loop voltage. And heater can be provided with 5 volts AC. Then sensitivity should be 200 at the value. Output voltage will be at 200 volts. Concentration level will be depends upon the formula. And we can also have temperature, humidity measurements, but that is for this BMV 280 sensor. Yes. So it is not only required that we should measure gases or particulate matter or any other unwanted particles. It's not only up to that. It is also we also need to measure temperature, humidity, pressure.
Kanchana, I think you have again the network issue. Yes, Darshan, what do you want to ask?
Good evening. Hello.
Yes, Darshan.
Actually, I had raised request on 18th of September for a submission letter, and till today, actually, I have not received any email or something update regarding that. Can you help me.
You have requested for completion letter,
No, probation letter.
probation letter. Okay,
Yes.
so when you requested, on which date?
18th of September.
18th of September. Okay, so it might possible that you may receive this week.
Okay.
Okay, so if you didn't get, then though I will talk to ma'am, then I will let you know.
Actually, I talked with Neha, ma'am. You
Okay.
might be knowing her, right?
Yeah, yes, yes.
So, yeah, I talked with her on Friday.
Okay.
So she told me that I have sent for approval and I will receive on, like, I will receive the letter on Monday. But
Okay.
yesterday also I actually waited. So I think today is also end of day now. So I'm
Okay,
not,
okay.
so yeah.
Okay, so I will ask her. It might possible that you may receive in this week itself.
Okay. Yeah, thank you. Yeah.
Okay, okay, very good. Okay, so Kanchana, you can continue where you left. Actually, I think you have a network issue more today. Kanchana, actually, I cannot see you. As well as your voice is also breaking a lot. Is it possible for you to continue? Because I cannot see you as well as I cannot able to hear you also.
Am I audible now, ma'am?
Yeah, now you are audible.
Yeah, ma'am. My screen is loading.
Okay.
So the BME 280 sensor, it will measure the pressure, temperature, and also humidity by taking the advantage of piezoresistive property. So the silicon and germanium will be having that property. Also, it will sense whenever there is a change in resistance. It will just it depends upon the mechanical load on them. So whenever there is a change in resistance, it will sense that and it will give the output to the output devices. We can have connections to this by having a Raspberry Pi board, as we have already discussed. So the block outputs of that can be read by the sensor, and all these pins connected will send the uh, data by the bus topology to the to the receiver by the use of transmitter, and then the output will be displayed on the LCD. So this also has some specifications. For example, operating temperature range. It can have minus 40 degrees to 85 degrees, and it will be measured in degrees Celsius. And supply current is IDD. Also, we can have the drain current from 1100 to 1 to 1100 microamps. And it is also, if we use an 82.5, it will be having temperature of 25 degrees. And that threshold value for it will be plus or minus 0.5. And absolute accuracy temperature will be from 0 to 65 degrees and minus 20 to 0 degrees also. And it also can have plus or minus 1 to 1.5 threshold value. And output resolution will be 0.01. RMS noise, if the noise is up to 0.005, it can be acceptable. So these are all the sensors which are used as an input devices for an air quality monitoring system. Again, I'm stressing that we can even have the change in ratings according to our particular application. We can have this for domestic applications, industrial applications along with. So we have discussed the average range ratings for using of all the applications. Actually, if we use average of the because for the required application, it will have different ratings. For that, it may cost low for us. And next comes the working principle. So the working is it receives all the information from the sensors and all the samples.
Kanchana, are you able to continue? Because there is a lot of network issue. Kanchana?
Computed by the Arduino or microcontrollers in the to the LCD display. Where it may be. These fall under 3 categories.
I guess she has a lot of network issues, so she's leaving the meeting. Kanchana, is it possible for you to continue because there is a lot of network issue? Otherwise, you can continue tomorrow from where
Yeah,
you left.
ma'am. Actually, it was completed, ma'am.
Okay, then
I
you
was
can
about to
go.
close in the next 5 minutes.
Okay.
Yeah, so these three are all the different categories of air quality monitors. One is lab grade, next is commercial grade, and the other one is consumer grade. And coming to the different types of categories, those are all again classified as subset into commercial grade. There are outdoor, induct, and air quality. Lab grade monitors are best sanitation mask monitors. These are also called as like they are used by the government scientists to gather air quality data to operate them and to detect some of the diagnosis methods. So these are actually very reserved. They will not available everywhere. Also, they are available in the high ratings with high weight and high non-portable accessibilities. So actually, that may not be useful for domestic applications and low-grade monitors. Coming to consumer grade, these fall into the total opposite of the lab grade monetary spectrum because these can be cheaper, this can be portable, even a domestic for domestic application also we can use these consumer grade monitors. These are used in outdoor, indoor applications like in home offices, hospitals application, etc. And coming to commercial grade, it is a split between both lab grade and consumer grade. So it will be in affordable, like average cost. It costs at around the average of both the lab grade and commercial grade, and also the weight, the accessibility, portability will also be in the average level of those do that. Sensor and Sense Mini monitors are primarily used kinds in this commercial grade. Actually, these are used toward building certifications and all. And coming to the sub-classification, we have outdoor, induct, and interior. Outdoor, it as the name says, it will be used only in the outdoor, and it measures particulate matter and ozone, which are the outdoor, which we observe that in the outdoors mode. And it also works to maximize the HVAC efficiency. That is one of the kind to use these outdoor air quality monitors. And induct monitors are very similar to interior monitors, where we have to use HVAC system, etc. Apart from using this to optimize the HVAC efficiency, this can save energy and reduce the unnecessary wear and tear. And coming to interior monitors, these are also located with building projects, but it will not work with maximizing the HVAC efficiency. Alongside, it will measure the toxic pollutants in the outside. So also in the outside and inside purposes also. Humidity, temperature. So BME sensor applications can be applied to this one. And pros, cons, and examples. There are a lot of advantages in these applications. As we see, it is low, it is less in weight, low in cost. Also, it is portable, and it can be useful for monitoring any type of gases, particulate matter, carbon dioxide, etc. For any kind of applications, it's starting from a domestic level, ranging to a big industrial purposes also. It ranging from all other applications in the real time. And coming to disadvantages, they suffer from some cross sensitivities. Like it should be so sensitive. As I have already said, even a point not 1% also affects the whole system application. So that it should be so sensitive and it should not be deviated from any other devices. So that can be so much important. And also it has a disadvantage that it can be caused by external factors, which it makes its maintenance is very high. As it is a device which can be uh, exhibited to the outer environment, we should also take care of the machines outside view and also the maintenance. So see, continuous emission monitoring systems, continuous optimum monitoring systems, and manual inspections are some of the examples in that. And let me switch to the PPT, ma'am.
Okay.
Yeah. So as we have already seen about all the components, key components present in the
Sorry to
quality
interrupt.
mentions.
You have switched.
Actually,
I cannot see a presentation. Kanchana, are you able to hear me?
am I audible now, ma'am?
Yes, yes, you're audible.
Yeah, ma'am. Yeah. Actually, my screen was loading, ma'am. I'll continue explaining.
Okay, okay.
Okay. So this is the prototype connection, ma'am. Here we can see the Arduino board and all the sensors are connected as per the wiring system we have seen in the circuit diagram. And for the overall Arduino board, we can use LED display, 4x20 LCD display, anything, or else we can range LM35 sensor and MQ135 sensor on the Arduino. So these are all the connections where we have to make. We have to make LM35 input output connections with 5 volts and ground, MQ also input output connections with 5 volts and A1 ground, and Q135 with input output with 5 volts and A2 ground. So these are the connections on LED. If it senses green, it is positive. If it senses red, it is positive and both negative for pin 3 and ground. If it senses green, it is positive and negative at pin 4. And if it senses red again, it will be at pin 5 and ground. The 4 positive and negative sensors will be activated. It will depend upon 4 LEDs we use. According to the each sensor, we can use different LEDs. And these are, we have already seen the different type of air quality monitors and pros and cons. So coming to the conclusion of this project, this is very important where we can use both combination of hardware and software can be included in that so that any engineer, embedded engineer can easily access this. Also, the what we have seen is we have collected what are the different components required for this. We have collected the data and ratings of each and every specification. So finally, we can collect data and ratings. We can send as input into the particular code or the processor, whichever code is required, and then we can simulate it and we can run it so that the output can be displayed in the software. Similarly, we can use it in the hardware systems also. So what is the future scope? Even we can use this with a GMS modules in the future. We can use it with different kinds of sensors. Also, as the technology is even more growing, we can also have a lot of real-time applications in future. Not only having uh, even with a smaller technology, it has started, but even with increasing technology, it has become portable with a lightweight also. So even in future, we can have a different customized sensors also. So whatever all the data is required, that can be only used. And apart from that, any disadvantages also can be diagnosed by using future technologies. So these are all the different websites that I have used. And if you have any questions, you can feel free to reach me. This is my contact ID. Thank you so much, ma'am.
Okay, okay. Your presentation is good, but today you faced a lot of network issue. So,
Yeah, ma'am.
okay, no problem. But when you give next time, so try to sit with a proper network connection. Okay.
Yeah, ma'am. Yeah, ma'am. That's for sure.
Okay, okay. So rest the way you
The network
demonstrate.
issue. Yeah,
Yeah,
ma'am.
yeah. What you were saying?
No, ma'am. Please continue.
Yeah, okay. So the way you demonstrated and using the block diagrams and example, that is really a good approach. So do you have any questions or want to ask something?
Yeah, ma'am. Actually, I'm really sorry to have these all network issues, ma'am. I didn't expected this. I've all set to give the presentation today. It's sudden. I don't know what happened with my laptop.
Okay, okay, no problem.
I can
Any
rectify this for my next time.
okay. So rest I will provide your scores and feedback on your email. Okay.
Okay, ma'am. Okay, ma'am.
Okay.
Thank you so much, ma'am.
Welcome. Okay, so we are done with our today presentation session. So we now wrap up our session. Thank you, everyone.